Myself Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri Shanmugha College of Engineering. In last lecture, we discussed about GRU, unsimplified GRU, and full version of GRU. And today we are going to look at LSTM, and LSTM is somewhat superior than GRU and simple RNN. Okay. Again, we are going to look at now what is simplified GRU, because it is going to be derived from simplified GRU. This is a hidden state at time step t at t, and this is basically a F is a forgot state, and G is basically a vanilla RNN, and this is the previous hidden state. Okay, so this takes care of the new information. This takes care of the old memory. Okay, this is takes care of this old memory and the new memory, whatever this is basically a new memory. The new memory is equal to, this belongs to the information. There is a new information, I can say. So this is a new information. Okay, so the old memory is basically, it's a summation of new information and the old memory. So this is F is equal to forget gate, and if I put it is if I put the value ranges from 0 to 1, and if I put the value of 1 here, and if I put the value of 1 here, we have old memory, and we will not have the new informations. So the value should be between 0 to 1, and then similarly if I put 1 here, we will not have a new memory, we will have only the old memory. And similarly, if you put 0 here and we will not have old memory, we will have only new information. So if you mix the proportion, if the value of f changes from 0 to 1, and we will have the combination of two things, that is, one is old memory and new informations. So this is what the simplified GRU says. Okay, and if you look at this LSTM, we have, this is a simplified version of LSTM, we will have the memory cell, and we have a previous hidden state. So there are two layers will be there, and one is the previous, this is a cell state, this is a previous hidden state. So that in LSTM we will have this memory cell that store the long-term informations. So the disadvantage of GRU and RNN is it doesn't have long range dependency. So in order to have that, and we use this memory cell state. Okay, so the memory cell state is basically can be derived from the similar equations like simplified GRU. Okay, so CT is equal to that is current cell state is equal to F into this is the point, this is the element is the multiplication, and this is CT minus 1, and this is here CT minus 1. Okay, this is CT. Okay, so there are two lines will be there, two lines will be there. This is HT. Okay, and this is the input gate. We will have here inside this rectangular box, we will have forget gate, input gate, that we are going to see in the next slide. And this is basically a input gate, and this is our vanilla RNN. Okay, this is vanilla RNN. So as I said, forget gate, it is basically, it removes that irrelevant informations basically, and that the input gate will take care of this information. So what I mean, if the I is equal to 1, it stores all the information. If I is equal to 0, it doesn't store any information. So the range, similarly the way we looked at F, and similar thing can be derived, can be implemented in I. Okay, so F is also the range of F varies from 0 to 1, and the I ranges from 0 to 1. Okay, so this is cell state. Okay, since we have this cell state, it doesn't have much of vanishing gradient issue. So the advantage of using LSTM is, when compared to RNN and GRU, then it doesn't have it doesn't affect the vanishing gradient issues. Okay, so that is the advantage of this architecture. Okay, so the corresponding hidden state can be written in terms of output gate and pointers multiplication of that activation function that's come from the cell state. Okay, this will come from here. You will have your activation gate. This is going to be output state. Okay, so basically the most three principles or three gates are very important in LSTM. One is forget gate. it removes the information. Okay, it doesn't, if it is a irrelevant information, it doesn't care about it. And the input information stores the informations basically. Then, and output gate reveals the memory whenever we need it. Basically, in human brain, and we see many things, and we will keep some information in our brain, and we will remove all irrelevant informations. Okay, so that's what we do. So similar logic has been applied over here. Okay, so the input gate stores information. If it is, suppose we keep the important things, and whenever we, over a period of time, we keep the important information, we neglect the irrelevant informations. So the input gate, whatever the input comes, and we'll observe whichever is important, that will go into our brain. So whenever that output is needed, we will take the combination of both. Okay, so that is the way it works here. Okay, so similarly, as I said, in LSTM we will have many parameters. Here we will have more of 8 parameters, 8 weight matrices to be updated in LSTM. Okay, so the output gate is basically a sigmoid function of Z0. This Z0 is basically a linear combination of vectors. Then forget gate is basically a sigmoid function of the linear combination of F, and I is the input gate, that is a sigmoid combination, a sigmoid of Zi. Okay, so this is the vanilla RNN, that here we use that tanh activation function. So this ZZ is basically a linear combination of vectors. So all these things are vectors. When we apply sigmoid in all these three gates, and all these three gates, okay, and we apply sigmoid in all three gates, and we apply tanh in the G. Okay, so this is a way it works. And when compared to GRU and when compared to LSTM, when compared to GRU and RNN, there is LSTM will have train more depth layers. Okay, LSTM will train more layers. Okay, so this is a way it works. Suppose when we want to work on, and we have to try with the RNN, and if it doesn't match with because that the information, there's some portion of previous information comes to the current state, but the long range independence is a question mark over here. Then it can be improved by GRU, because we use that remember gate. And in LSTM, LSTM is somewhat superior than other two architectures. So this is a schematic diagram of LSTM, and whatever we discussed, there are three gates. Okay, one is for forget gate, and another one is input gate, and another one is output gate. So there are three inputs, I can say. This is the current cell state, previous current cell state and previous hidden state, and this is our input. Okay, there are three things. Okay, and this is our vanilla RNN. Okay, so vanilla RNN, and this is basically our, this comes from the previous current cell state, and it is, we apply a forgot state, and the forgot state will erase whatever the information that we wanted to keep, that can be changed, that can be adjusted here. And similarly, then whatever the input comes, then after applying the tanh function over here, and it will go to the input state. Okay, so that input state will send the information to the cell state, and there we will have a elementary small multiplications, and again it comes back to output gate. Okay, this is, here we apply a tanh function, then here it will go, the output gate will take care of the what are the information that it has to be sent from the memory. So this is a simplified architecture of LSTM, since we use a cell state, and it doesn't encounter this vanishing gradient problem. Thank you.